Hello everyone, I'm Cheng Wang. In this video, I'm going to present our paper, Shared Realities, Avatar Identification and Privacy Concern in Reconstructed Experiences. My courses are Sandhya Sriram, Andrea Stevenson Wang, and we are from Virtual Embodiment Lab, Cornell University. As we know, people share experience with photo and videos today. However, photos and video only allow us to relive the experience from the perspective where the camera was captured. In this paper, we present ReliveReality, a prototype that allows users to reconstruct their 3D experiences in 3D. So you can see here, people can actually move around in the reconstructed environment and view the experiences from any perspective. Let's look at how we implemented ReliveReality first. And that's starting from reconstructing the avatars. To reconstruct the avatar, we utilize a state-of-the-art deep learning-based technique so that user can just take their front and back photos. Then we can generate the highly detailed avatar as you can see in the right videos. And once we have avatar, we still need the texture. We utilize projection from view feature in the Blender so that we can project the front and back photo directly to the avatars. And to able to animate the avatar later, we utilize Adobe Maximo online rigging tool to quickly rigging our generated avatars. Let's look at how we reconstruct the 3D motions. In the left video, you can see we utilize another deep learning-based computer vision technique to allow us to reconstruct 3D motion directly from 2D videos. And once we get those videos, those motions, then we wrote a constant script to retalk those motions to our generated avatar. Once we have the avatars and the motion, the last thing we need is the 3D environment. To do this, we utilize Mesh-Stream, a photogrammetric tool, so that user can just take many photos about their environment, and then they can generate a 3D reconstruction result about their environment. After that, we integrate all this result into a social virtual environment, Mozilla Hub. As you can see one example here, then people can generate a web link and share this link to others. Then others can, just like here in the video, move around in their experiences and view the experience from any perspective. Our prototype also allows users to apply blurring effect to hide the details in the reconstructed experiences. And this will be utilized in our study later. Now, ReliveReality allows users to relive their experience 3D and share this experience to others. We argue that this provides a new way of experience sharing method, but it also raises a new privacy concerns. And we also think it's critical to understand how participants relate themselves to their reconstructed avatar. So we conduct a study, a two-stage study within subject design with 38 participants. In the first stage, the goal is to let participants have something to share in the second stage of the study. So in the first stage, participants were asked to mimic a funny dance and record themselves and prepare other material for the reconstructions. As you can see here, after getting the materials, we generate 38 total unique reconstruction experience for every participant. Here are some examples demonstrated in this video. As you can see, you can move around, see the details in the environment, and also the motion from the participants. This is another one of the example. So after we generate the reconstruction result, 1 week later, participants came back to complete a second stage. The second stage study is in the second stage of the study, participants were asked to relive their experience in 3 conditions. The first is viewing a video, the second is ReliveReality, and the third one is BlurReality, which we apply the blurring effect to the reconstruction result. In the following slide, I'm going to demonstrate some study results in terms of the avatar identifications. Our study results suggest that participants identify more with reconstructed avatar than the blurry avatars. However, we also found that they still view the avatar as their virtual representation, not the real themselves. So they less identify avatars than themselves in the videos. On the other hand, because participants can move around in the reconstructed experience and view the experience from many different perspectives, so they have significantly higher level of presence in both ReliveReality, BlurReality than the view video condition. In terms of sharing behavior, in each condition, we ask participants how comfortable they feel when sharing the experience with different recipients. We classify recipients into 9 different groups based on social relationship, from significant others, close family members, to someone they don't know. As you can see in these figures, we saw there's a differences between sharing with strong ties and sharing with weak ties. Let's look at strong ties case first. To share experience to someone they know well, participants are comfortable all in 3 conditions. However, they rated ReliveReality as the most favorable sharing experience with strong ties because they believe others can know more detail about their experience without the blurring effect. And ReliveReality allows them to move around in their environment. On the other hand, for the weak ties, when sharing to someone they don't know well, we found there's significant difference among 3 conditions. In this case, participants are more comfortable to share the experience with BlurReality. And they also rated BlurReality the most favorable method when sharing with weak ties. The main reason is because BlurReality can better preserve their privacy. We also found 3 other interesting findings. Due to the time constraints, I will only describe it a little bit here, but you can find more details in our paper. The first one is we already know that people have less identification with their avatars, but we also found that they still feel them connected to their avatars and view those avatars as part of them. So that's why they still feel less comfortable to share to someone they don't know. In other words, they still have privacy concern to their avatars. In addition to the avatar, they also raise privacy concern about reconstructing environment because now other people can relive their experience, move around in their environment to see some detail that hard to see in the videos. The last one is the blurring preserved privacy. The blurring preserved privacy, but we also found that it significantly reduced the presence and the certification. In other words, it's critical to explore more obfuscation technique, particularly for the 3D reconstruction experiences. Based on our result, we also propose some design implication. Due to the constraint, I will only demonstrate 2 of them. The first one is enabling selective sharing for 3D reconstructed content. For most of the 3D model platform right now, they only provide really basic recipient control mechanism. So in the future, we definitely need more fine-grained recipient control mechanism because our study results have already demonstrated people have different privacy concerns for different recipients. The other design implication is we can let the system or adapt the 3D reconstructed content based on different recipients. For example, here that to share a 3D reconstruct experience to different recipients. For example, for families, they can view the every detail about the experiences. But if the experience was viewed by other strangers, then they can only view that same experience with less detail, just like you make a cartoonish avatar instead of photorealistic avatar. Thank you for listening. Please find more detail in our paper or welcome to chat with us at CSCW 2021. Thank you.